Excellent. Cool. Okay. Well, this morning I'm going to be talking about the E part of the ESG toolbox, and that's mainly the environmental part. And what I'm going to be talking about is how you can minimize your environmental impact to maximize your environmental credentials. And why is this specifically important? I'm sure everyone here has heard about this whole green agenda, decarbonization trends. And even though it also is an opportunity for mining companies in terms of the raw materials required, it's also a major risk, especially the lack of decarbonization. For example, legislation associated with the green agenda. And what we're seeing quite a lot recently is that a lot of junior mining projects are integrating unsubstantiated green credentials to boost the way their projects are perceived. So to give you a few examples, some of my personal favorites, how they describe their projects: lower CO2 emissions, low carbon technology, minimum water use, environmentally friendly and sustainable. And the thing that we probably ask ourselves on a daily basis is, but have they actually done a life cycle assessment? And now to kind of talk about what a life cycle assessment is, or also an LCA, basically what it is, it's an inventory of both the global and the local environmental impacts related to producing a product or a process to produce a product. And the image that you see here on the right is a bit of a schematic figure. What we then look at all the inputs going into a process and all the outputs to produce what we then call the main product, or the functional unit, to talk a bit in jargon. And a life cycle assessment tends to include a range of environmental impacts. So the most popular one at the moment is the carbon intensity, and I'll be talking about for the majority of that for this presentation. But water use also is gaining more traction. And what I personally really like about doing an LCA is that it doesn't just provide you, for example, the carbon footprint of your product, but it also provides you insights into like the environmental hotspots of your process. So for example, if you look at the different processes that we see here in the middle, you can look at the different energy and raw materials required for certain unit processes. And in that way, you identify the environmental hotspots in your process. And with that, you can again look into perhaps any mitigation strategies. And in that way, we get the raw materials required for this low carbon economy that we all talk about at actually minimum environmental impact. So the way that we see it is that understanding, quantifying, and mitigating those impacts by using a life cycle assessment is probably scientifically the most robust methodology to underpin the environmental pillar of the ESG triangle. And so let's talk about the carbon footprint, because this is quite well reported on in the mining industry at the moment. But the mining industry usually talks a bit more about the foreground processes. That's what they call a greenhouse gas analysis. And what they tend to differentiate in, especially for the greenhouse gases, are the scope 1, 2, and 3 emissions. And scope 1 emissions are the impacts associated with, for example, direct combustion of fuels on site. So think about, for example, the diesel consumed by a haulage fleet. Scope 2 emissions, you look at for example, the embodied carbon footprint of the electricity that you consume on site. And scope 3 emissions, those are usually not reported upon, and but they are an inherent part of doing a life cycle assessment. And for example, if we look at the figure that we have here in the bottom, scope 3 emissions can be both upstream or downstream scope 3 emissions. And what we tend to look at, and what we think all mining companies should kind of think about, are also the upstream scope 3 emissions, because then you're looking at the embodied impacts associated with the materials that you use to produce your kilogram of copper cathode, for example. And in the same way that we are currently saying that, for example, a Tesla needs to have a low carbon footprint for the batteries, in that way, a mining company should think about the environmental footprint of the reagents that they are using. So the way that we see it, scope 1, 2, and upstream scope 3 impacts are the responsibility of the miner, and the downstream scope 3 impacts are not the responsibility of the miner. And I think in a previous presentation, I was really happy to hear Teresa talk about integrating the ESG metrics already as early on as possible, because I couldn't agree more. Because what you see here, for example, is that from the moment, what you see here is the development stages that a resource project will go through. And actually from the moment that you move into construction, the odds are of you influencing or changing anything in your process or project setup, it's going to be minimum, because you've spent all this capital to build a mine. You're not going to add any additional risk by trying a new reagent. You're not going to spend additional few $1 million to get some renewable energy sources because you need to get your return on investment. So by integrating these lifecycle assessment metrics throughout the different development stages of a project, you actually have the possibility to get these quantitative environmental impact data to supplement, for example, your production volumes and the costs associated with that. So the way that we see it, you probably, from the moment you design your first flow sheet, you're doing a scoping study, that's when you also should carry out your first life cycle assessment. And now I'll walk through a case study. This is an example that we've done for a lithium project in development. And what we're going to be looking at is producing at the life cycle impact of producing 1 kilogram of a lithium product from the same deposit using 2 different flow sheets. And what we see here on the right is what we call the system boundary. So these are 2 different routes that we're looking at. And the first route, we're looking at a hydrometallurgical flow sheet where the ore is leached, the impurities are removed, and the product is precipitated. And basically, the second flow sheet, the one that you see in the brown color, is quite identical, but there's a concentrating step in the middle, which means that we're removing some waste before we go into the hydrometallurgical process. And a small disclaimer, I won't be talking about the impact of the mining stage just yet, because usually people tend to design the process first and then they build the mine plan around that. So if we look at what contributes to the carbon footprint of the 1 kilogram of lithium product for route 1, we can see that more than 70% of the impact actually comes from upstream scope 3 emissions. And that, just to remind you, that's the embodied impact of the used reagents. And these are the values that currently mining companies are not reporting on. And that's, I think, is quite mind-blowing. So the direct emissions for their scope 1 account for about 20% of the carbon footprint of the lithium product, and the impact of the utilities, they account for about 90% of the impact. And this shows then the importance of understanding these upstream scope 3 emissions when you're developing a project. It doesn't just influence the OPEX, so the costs of producing your lithium, but it also really influences the environmental credentials. So now let's take a look at how it then compares if we're looking at the carbon footprint of the upgraded ore versus the non-upgraded ore. And we can see from this figure on the right is that for the upgraded ore, the carbon footprint is less than half than it is for compared to the carbon footprint of the upgraded ore. And the majority of the savings actually originate from a reduction in the amount of reagents that are required. So if we compare this against the original scenario, the relative contribution decreases from 71% to 26%. And I already mentioned that in this case, we haven't included the impact associated with, for example, the fuel used in the mining stages or the explosives that are used. So realistically, most likely the impact of the upgraded ore will increase, won't be less than half what it would be of the non-upgraded ore, because we'll lose some material in our concentration process, which means that we'll need to linearly increase the amount of fuel required to haul ore and to loosen it, for example, with explosives. And actually what we're seeing at the moment is that using life cycle assessment in critical metal project development is getting more and more recognition. And just to go through a few examples. So probably one of the most famous one in Europe at the moment is from a project owned by Vulcan Energy Resources. So they're producing battery-grade lithium hydroxide, lithium being a metal critical for the energy transition, while simultaneously exporting electricity to the German grid. And by doing that, using LCA, it actually shows that the carbon footprint of the product is negative. Another very interesting case that we've seen is where they produce vanadium pentoxide from steel slag waste. And what I think is really interesting about that project is that they sequester carbon dioxide from the atmosphere and add it into the process as a reagent. And by doing this, they also have a carbon footprint of their project that's negative. Talking about a different critical metal, nickel, there's currently a project under development where they're using what they call a new innovative process called the direct nickel process, where they're producing battery-grade nickel sulfide from laterite ores. And what they're trying to do is they're trying to get the natural gas for their thermal energy. They're trying to capture that from methane that would normally be directly emitted, so what they call vented into the atmosphere. And they receive a credit for that, which gives them the opportunity also to have a very low or negative product carbon footprint. And definitely make sure to watch Minviro's LinkedIn or follow us, check out our website, because in the short term, we'll be working with a major software mine planning company to integrate these metrics into their mine planning and mine optimization to gain as early on as possible, like the life of mine insights into these environmental impacts. So I've been mainly talking about the global warming potential or the carbon footprint over the last few minutes. But what I really like about life cycle assessment is that it quantifies all the different possible environmental impacts. Some of them are not as relevant for mining as others are. For example, the ones that are in orange aren't as relevant. They're mainly relevant for the chemical industry, but the ones in green are relevant. So in this case, a global warming potential, they're already talked about, also particulate matter. So looking at, for example, the effects on human health. Also looking at acidification, and this is mainly really relevant for sulfide minerals, but also land use. We already talked about mine closure earlier on today, but also water use, which is becoming more and more important. And what we are currently working on, it's not finished just yet. We're working on a state-of-the-art LCA tool that can really supplement this ESG toolbox. It's a platform called Mine LCA. And what we're trying to do is make sure that basically everyone can have access to life cycle thinking into project development as early on as possible. They don't need to hire an expensive LCA consultant for that, but they can actually get these quantitative and environmental metrics as early on as possible. And as it says here, in that way, you get life cycle thinking enabled for all. And I'm personally a really big fan of making these environmentally informed decisions, because you can, by using this LCA scenario analysis, you can look at your different project options, you can evaluate the impacts in the full lifecycle context, and you can use this data to really supplement the decision-making for the technical and economic data that you already have. And I think a really cool trend that we've recently been noticing is that a lot of companies are having the interest of integrating this data in their sustainability reporting, but also in their the reporting that they're doing for their the resource projects and development for example, following the your guidelines or the NI 43-101 guidelines. I think that's a really cool development. And now, I guess, going back kind of to the title slides, by using this LCA approach within the ESG context, you can indeed minimize your environmental impact at maximum flexibility, and in this way, really selecting the least environmentally impactful route and maximize the environmental component of your ESG triangle. Thank you.
Fantastic. Thank you so much, Lawrence. Tijsseling, I've learned, is your last name. Fantastic. You can't manage what you can't measure. That's sort of
absolutely.
I'm going to start with a question from Dan on YouTube. I'm going to read it here. Scope 3 emission reporting seems really poor and really variable across mining, all metals. Are the GHG protocols and GRI type standards too flexible on this? Some companies publish methods, at least.
That's a really interesting question. I wouldn't say it's too flexible just yet. I guess it's about companies and people getting used to it themselves as well. As in, we've come from a long way where we didn't even talk about scope 1 or scope 2 emissions. So what we tend to notice is that the world is moving in that direction. But to make sure that you get everyone on board at the same time, you need to take baby steps. So I think in the future, as life cycle assessment and upstream scope 3 emissions become more important, people will get more aware of it. I think maybe the guidelines will become more tight on that as well. But it's about making sure that the companies can move in the right direction, and they're big and they need time for this. And I think they're not too flexible, but they're getting in the right direction.
And we have another one here from Haluk. There are many regulations. I mean, these are great questions, so I'm just going to keep reading what people are sending in here. There are many regulations about EIA, and this have been updated by country to country. Also, LCA has some limits and scopes based on these regulations and projects aim. So how can we manage or analyze LCI? Is there any national standards or applicable base checklist for projects?
Unfortunately, not yet. And that's really quite frustrating. So if you look at the LCA guidelines, these are global ISO standards. What you notice is that there's a lot of flexibility that's been given to the LCA practitioner, so the person carrying out the LCA. So actually, one thing that we are working on with certain global LCA, let's say, the communities, is what we call development of a product category rule, which basically is a set of guidelines of what you should and shouldn't include in an LCA, which can then be third-party verified to make sure that actually the decisions you've made align with the standards set out for these different LCA methodologies. So also there, unfortunately, we're not there yet. However, there are some movements where people are going to do this, for example, for lithium, for graphite, because having data for that is really important. To answer your question about the environmental impact assessment, so the way that we see it, so LCA is quite good at capturing impacts on a global level, a bit less on a regional scale, and that's where the EIA comes in really handy, and the two really should support each other and not exclude each other out.
Mm-hmm. And for the audience, Sarah is sort of typing all the abbreviations, what they mean if it's too much jargon. So keep a check on that if you feel like you're getting lost. EIA, environmental impact assessment. Lawrence, one thing that I was just thinking of is a lot of companies are now, they have sort of a net zero target when it comes to carbon emissions in, well, 2050 or something like that. What do you think about that as a target for the industry?
Great. In the end, it's about making the statement to make sure that they are going to commit to it. I think realistically, they will initially do it to please their shareholders and to make sure that the communities they work in know what they're doing. And then the next thing they do is that they're going to try and figure out how they're going to get to it. Mm-hmm. But I think it's a really positive development because it means that they are going to commit capital and resources to gaining these insights as they're moving towards that net zero strategy. But one important thing to keep in mind is that, because we've been involved with some of these projects as well, is that they're then looking at being net zero in terms of scope 1 and scope 2, and not as much yet scope 3. So I guess if every company moves towards net zero for scope 1 and scope 2 themselves, we will be. But I think it's of course important to understand that the companies are aware of their responsibilities from that perspective as well.
And why do you think the critical metals companies are more interested in these issues than maybe some other companies?
The money that's associated with it. I think if they know if they know they are the minimum impact if they deliver the minimum impact products of the industry, they are going to be able to get a premium price compared to the other metals out there, or they're going to be able to set up long-term supply agreements. In the end, everyone's pointing towards electric mobility as being the savior of the world. But the issue is that a lot of LCA studies that have been carried out to prove this are based on outdated data sets. So they don't really have this insight yet on this full supply chain. So if they want to get the attention of a Volkswagen, they want to get the attention of a Tesla, they need to have this data. So those are the first areas where these steps are being made. But I think for the other commodities, it become more important as well.
So fantastic. This is really a topic to keep a close eye on. It's getting more and more topical. Thank you so much for a brilliant presentation and answering all our difficult questions. A round of applause, everyone. Thank you.
Thank you very much.
We are quickly moving on.